So what I will present today is the activity of the MOST, that is Centro Nazionale per la Mobilità Sostenibile. Okay, so first, what is MOST? So il Centro Nazionale per la Mobilità Sostenibile has been created with the ambition to support the development of a new way of sustainable mobility. So the more sustainable mobility will be a mobility that will be greener, safer, more resilient, accessible, competitive, and collaborative. MOST is organized with this structure with a hub and a spoke. So we have a central hub that is coordinating the activity of 14 spokes dedicated to different parts of the ecosystem that compose mobility. The hub manages the program in terms of resources allocation, innovation and education, and initiatives to globally increment the TRL of the projects, while we have several spokes that will work really on the research at high TRL with a collaboration between universities and private companies, and development of local infrastructures and laboratory at the state of the art. So right now we have 25 universities in Italy that are collaborating in MOST together with research centers, and 24 companies that are major companies operating in Italy in the sector of mobility. So we have Ferrovie Italiane, Autostrade, Ferrari, Pirelli, Poste Italiane, and of course also aerospace companies like Leonardo and Avio Aero. The structure of MOST is a structure, a matrix structure. So on the vertical axis, basically, we have the vectors. We have the 5 main vectors of mobility that we are considering. So air mobility, sustainable road vehicle, waterways, railway and transport, and light vehicles. While on the horizontal axis, we have the technologies that are across all vehicles and systems of mobility. So we have a spoke dedicated to connected and autonomous vehicles. We have a spoke dedicated to smart infrastructure, to innovative service, to urban mobility, freight and logistics, innovative material, propulsion, electric traction system, and hydrogen. In particular, today I'm going to talk about the spoke air mobility, since we are talking here about aerospace. The spoke of air mobility is organized between 5 main universities, is led by Politecnico di Torino, then of course we have Politecnico di Milano, University of Bergamo, Bologna, Federico II, and La Sapienza from Rome. And we have the collaboration of 6 major private companies, Avio Aero, Thales Alenia Space, Teoresi, Accenture, Leonardo, and Poste Italiane. The objective are, on one side, the development at spoke-wide level of drones, cargo drones, and urban and advanced air mobility. And on the other side, the development of hybrid electric aircraft, and so technologies that will allow the implementation of hybrid electric aircraft. And on the other side, we have the groups that are working on the development of digital twins and on the development of passenger and goods management in the developed new mobility system. So the spoke is organized around 6 work packages. And in particular, I'm going to talk about the first work package that is dedicated to a sustainable design and structural acceptance of advanced air mobility. So the focus is really on how we can develop advanced air mobility that could be sustainable and accepted by the public. So this is where we would like to get. This is a render, of course, of what could be the implementation of urban air mobility in our system. Sorry, I need to go. Is there a way to go back? Yeah. So this is a render. Of course, it's Milano. I'm coming from Politecnico di Milano, but hopefully we will see this type of scenes in the future, not only in Milano, but everywhere in Italy and, of course, in Europe and the world. Maybe next time I will show a picture of Bari with the urban air mobility implemented there, and maybe could be not a rendering, but a picture of a real situation happening. If we want to reach this goal, so to have those vehicles fly in our cities, there are still some technological hurdles that we have to overcome, but there is also another related to acceptance of those type of vehicles in the urban environment. So the object of the activity of the spoke one of the most dedicated to advanced air mobility is really on the acceptance of those type of vehicles. So we developed several tasks in order to investigate the element that will mostly affect the acceptance of those type of mobility in the urban environment. In particular, we're going to work on the noise acceptance of operations, and so understanding how safe operations could be implemented in the urban environment. Acceptance related to sustainable material, safety of batteries, and in particular, what could happen if a battery pack impacts the ground, and acceptance of infrastructure and community acceptance. I will present just a couple of labs that we are developing. One is a lab dedicated to batteries. A major safety concern is related to the possible impact of batteries on ground. So we are developing drop tower to drop batteries on different surfaces, ground surfaces, also water, so to understand what is the consequence of an impact of a battery pack, and to design systems that can manage the energy generated in the impact in order to have a safe impact that will not generate any hazard for the public. The second lab we are developing is the lab dedicated to noise. So we are developing a new anechoic wind tunnel. Politecnico di Milano, we have a long tradition of wind tunnels. We have a large wind tunnel and a small wind tunnel that are already full operative, and now we're going to build this noise wind tunnel in order to test noise developed by urban air mobility vehicles, and so assess again what could be the impact of those vehicles in the communities that will see those type of mobility implemented. The third lab I want to talk about is the lab of certification by simulation. Already Cristina Leone was talking before me about digital twins and the necessity to develop those digital twins also to perform certification activity. The objective we have here is to recreate the environment, the complex wind environment that is generated when those type of vehicles fly close to obstacles, get the data out of test labs and inject those data in a digital twin that will perform a digital simulation, maybe using virtual reality, to assess the safety of different operations in different environmental conditions in this system. All those things will eventually converge into a physical lab that we are trying to develop over the Bresso Airport in Milano. Bresso Airport in Milano is a city airport that is really embedded in the city, in the city of Bresso, very close to Milano. So it is really a prototype of what could be a urban vertiport that could be used as a hub for this type of mobility. So the idea we have at Politecnico di Milano in particular is to develop their testing facility in order to test how urban mobility can operate in a complex urban environment, such as the one of Milano. The last thing I want to talk is related to a testing activity that we are trying to perform together with our partner, with our industrial partner in the Spoke 1 dedicated to air mobility. That is the case of middle-mile drone delivery on minor islands that will be developed, by Poste Italiane in collaboration with Leonardo and with the support of the different labs of the Spoke 1 of MOST. The objective of this use case is to implement an activity to transport parcels and mail in difficult-to-reach areas, in particular onto islands, in order to test if we really have the capability to offer a service, so not only to do a simple experiment once, but to offer a continuous service of transmission of parcels and mail. So the testing activity will allow us to analyze if we have the enabling factors to be able to implement such a service, and also to understand what will be the social acceptance, again, of this type of drone mobility and drone flight on the communities that will see those new systems of mobility implemented in their local area. So this is going to be the structure of the testing service. So the service will start from a center of collection of mails and parcels where road transport will be used to transfer those parcels in the delivery center. From the delivery center, the parcels will go into a vertiport where it will be charged on a drone. The drone will fly to the islands. On the islands, the drone will land. The parcels will be unloaded by the drone, and then using again a mobility system will be transferred to the different distribution centers on the islands. So in conclusion, I can say that there are a lot of activities that we are performing in MOST in order to make urban and advanced air mobility a success, hopefully. So we hope to see this type of mobility implemented in the near future in all our cities. And we expect the facilities, the testing facilities that we are currently developing in MOST to support the capability of the Italian ecosystem to implement technologies to realize the advanced air mobility. Thank you very much for your attention, and I will leave the floor to the rest.